Hello. Welcome to part 13 of my Wolves on the BackBit series. Now 13 in this case is not an unlucky number because, well, I made a rather lucky discovery in this clip. You see, in 2019 or 2020, I can't remember which, a local radio station for their New Year's Eve countdown played the best 963 songs of all time in no particular order. And that's what bothered me because they did this in years past. And what they would do is, just regular programming, it seemed. But every so often they're like, here's song number 194. And then they'd play something. And you're like, I guess that's 194, because who keeps track, right? But the thing is, they never played like song 12 or, Stairway to Heaven or anything that you think would be remotely near the top. So everything was up in the air. And I smelled something fishy going on. So this year, I was ready for it. I recorded 38 hours of that radio station nonstop. And I was going to make a video and basically expose this fake countdown because it bothered me. Don't say it's in no particular order countdown when it's not. And I have proof that it is fake, but I never made the video. The thing is, I was browsing through the footage. Even on a media player on a PC was difficult. On the PlayStation 3, it was next to impossible. One wrong button press and the thing resets itself. But fast forward to 2021, and hey, I got the BackBit now. And lo and behold, a 3 gigabyte audio file was as easy to jump through as anything else. And so what I did is I was experimenting with it, and I guess you'll see. I can't play anything of any length here because, YouTube's going to detect a certain song and all of a sudden everybody's going to have a big hubbub about it. So you can tell that I've got the radio player jumping around here and there and here and there, using mostly the code that expects a video with wolves in it. So the video itself is nothing but audio data. So it's all corruption. So if you don't like flashing, well, don't worry, the warning will come too. But yeah, this isn't one for you. So where's the lucky discovery, eh? Well, I guess that's the clickbait. You'll have to watch and find out. But I was glad I did this. I didn't make the video. Maybe I will in the future because, I want, I just want to clear the air here because this still bothers me. Don't do stuff like this. I don't care. Yeah, you're getting people to listen thinking that it's a countdown, but it's not. Anyway, sorry, I'm ranting here. I should really save this for the video itself, if I ever make it. But, well, let's get to it. Part 13, a lucky discovery. How does this relate to my current project? You'll see. It's cool. All right, let's watch. I just hacked this into my old Gabu player with different audio and deliberately skipping over chunks of it a lot so I avoid YouTube content detection. Here we go.
And Westmoreland. For this holiday.
Now, while I hacked the wolf playing code just to try out that radio sample, I made sure the audio started to queue up a 32-bit value because you go through 16 megabytes in almost no time flat if you're jumping through song to song like I was doing. However, if this is true, using the 32-bit access routine on the BackBit, look at the delay times versus the 24-bit version. Oh my God, if that is real, look at the savings here. What is, oh man. Okay, if this, I'm going to try this with the real player. And if this is the case, 24-bit, fuck you. Never use it. 32-bit for the win. Look at that. Wow. I got to try it right now. All right, I just played through my little wolf video with no modifications. And these are the cycles of delay for the BBT access, for the audio stream, the video stream. So I'm going to switch one of these, probably the audio, because it's going to be the easiest to do. It's not really much different between either of them. But I'm going to switch the audio to a 32-bit queue up instead of a 24. And we'll see if that makes a difference like it did before with the radio player. This will be interesting. Here we go.
You gone bonkers? 'Cause you're so hungry? Nah, I'm feeling great. My toothache just got better. Just excited, that's all.
All right, you ready for the verdict? I'm going to close my eyes for a moment and then hit break. Damn! So why was the audio fetching so fast on the radio player? I gotta check my work, make sure I actually am queuing up a 32-bit here. Why? Why? Well, this is a head scratcher. Look at the audio queue times this time around. Now, just for kicks. Now, this first bit, there's no such thing as frames. It's reading from the wrong area. Same thing with this. That's all bogus. The audio-video data, or the times here, are accurate. Now, you notice the audio queue, the memory times, go up, and at some point, go down. And the fluke when it does a frame. But I'm guessing internally it becomes closer and closer to the top of a page or whatever, and then all of a sudden drops and becomes easier, faster for it to access, by microseconds, whatever. And 36, 37,000. Although I'm only going to get 255 readings here. This makes more sense because at this point, the fake video stream is still relatively lower in the file. But for these, it's jumping pretty far. How far am I jumping in each one? There, AudioMem2, which is, let's see, 65. So, times 65536. It's jumping by 1 megabyte every time this queues up. So, you can imagine, 255 later, right? It's already, how big is that number? 300 megabytes into the file. So it's taking, almost a 1/16 of a second to queue that up, which is reasonable. I mean, I can still jump around like a badass with almost no noticeable delay, which is what I plan to do, but I don't know what those first numbers were. I was so excited. I thought I had it, but realistically, this makes more sense. Sucks, though. That's too bad. I wonder if the BackBit Pro has a faster access time. I'm going to be buying one of those soon anyways.
Nah, I'm feeling great. My toothache just got better. Just excited, that's all.
All right, what was the point of that? Check this out. Well, despite this is my best display rate yet, but look at the access times. they're all, except for the one that, you know, happens to have the break for the update, the frame update, takes longer, right? So 178 audio refreshes, 186 video stream queues. Okay, I gotta remember that because it's gonna go off the screen. 178, 186. Okay, 178, 186. 364 total accesses, but as you can notice, these times are about 20,000 cycles less on average now. So that is there. What is that? 7 million. That's about 7 seconds of absolute going in a circle CPU time that is no longer occurring. And why? It wasn't the 32-bit access, but I hacked this in. I had a thought last night. Maybe it's affecting my dreams. I've had really bad dreams lately. A lot of it's to do with this code. I changed this. 2 things. One of them right here. Because there's a SD to IEC header of 26 bytes. I skipped it. I made it an even page. The other one, let's see, is over, where are you? 300 and some, okay. There it is. Oh, crap. It too is 26 bytes offset, right? But I'll leave that one as 0 because I changed it to 20, from 26 to 0. The 27 happens to become the 8580 stream. Is it actually, for some reason, I accidentally padded the 6581 with a carriage return or something at the end. So even though the 8580 immediately follows it, it's no longer perfectly offset page-wise. So I've reset the video pointer. Now it's going to be on track video-wise, but the access times are going to be slower, right? So I can break out of this anytime I want. There. Watch. It'll be quick on the audio, slow on the video. Sure enough, right? Ha! And there it is. It's not a 32-bit access. It's requesting things on even page boundaries. Now, I don't know if you requested things on an even 64-page boundary, would it get even faster? But still, that's pretty quick. We've went from, as per the instructions, what is that? Well, 25 to 40 milliseconds. Well, the 40 doesn't count because it's doing a refresh. But down to an average of 5 or 6. That is critical. So in the future, and I'm going to rework this BBT to get these savings here just because I'm, well, 97%? No, just because there were so few frames being rendered here. I'll turn this down. Because I was going to struggle through and make it so the color RAM wasn't buffered only for, let's see, no, I was going to make it so the color RAM was sent to the D800 area on a frame by frame basis, not buffered, and only buffer 1 frame on the way out. Now to do that I have to keep track of which page on the BBT, or, oh man, I just woke up. I would have to keep track of if the video stream is currently queued up and also keep track of which page is currently being accessed, because the copy of color to the color RAM happens via interrupt. So when it's done that, it has to put that page back because it could be in the middle of my generic data inbringer code for the bitmap. But in doing so, just to run a demo last night, I was getting better readings. Like my 88% became 90-something%, you know, just pretending that this was already done by just basically skipping the buffering of the color information. So if that makes sense to you, great. I'm probably going to edit all this out. But anyway, let's get out of here and look at the data that we have so far. There, 91%. And because of the slow video, right? So let's change that video back. Where was that? 2500, right? Change that quickly to a 0. And this is where it screws everything up, because at the moment it's throwing everything off by that amount. Oops, you don't sys that. So it's now throwing the bitmap read off, the pointers for the color, pointers for the video matrix. For some reason, the bitmap itself seems to be shifted over way more than 26. But I don't know why that is. But anyways. I like how a simple change corrupts everything. And you see this this line here. This is now the edge, the left edge. And see, here he is. He's over here. Why is 26 changing this much in the bitmap? You think 26 would be like 1, 2, 3 characters in a little bit. I could think about that. I'm sure there's a reason, but it doesn't really matter right now. I'm just getting some data here. So what I got to do is rework this BBT and chop out that SD to IEC header. Make sure everything aligns to pages, whether it's video or the beginning of the audio streams, because when a jump happens inside the stream, it's always to even page boundaries anyway. But internally, previously, the lowest byte of the video stream was always 26, and of the audio stream, it was always 26 or 27. That needs to be 0, 0, and 0, and that's how you take advantage of this extra speed. Okay, enough data. Let's go see what we got. Before it was 93%. It's probably still 93%. Yes, it is. But without it, well, you saw what I was getting last night, because I'm sure I already showed it. And the only thing I did here is just change my BBT up a bit. Although this is just a quick hack in the morning. Like I said, I just woke up. But look at these access times. That's real. And that is based on, it's basically a simple calculation, taking the timer values and subtracting them from a full, you know, and that's it. So, and the timer that counts is a one-shot deal. So it will reset itself. There we go. One shot, and I do a force load and a timer start, right? So that is all it's doing. And let's find a code that does that. Where are you? Q audio. There we go. There. We start the timer, and then we zero this bump frame, because every frame jump will increase that. Get our index ready, increase the amount of audio fill counter, and here's the part where it waits. And when it's done waiting, it just puts the current timer value into those two pages and flags whether a frame was introduced during that wait. And because this can only happen, well, any value you get is going to be legitimate, unless the timer reset itself, at which point you're going to get either 65536 or 0, I forget which, but you'll know when you see it, right? Because you're going to get a bunch of junk. Now these at the bottom here are because all the 65536s are because the first thing I do is zero out the entire page. Come on, there they are. And interesting to note here, sometimes there's fewer audio fetches than video fetches. Now, that is partially because I think, is it at 500? No, it's at 400. If the audio page is already in the same zone as the reading pointer, it just takes off anyway. and it won't bother to increase itself, which is down here. Anyway, 14 minutes. Yo. Yeah. But how do I take advantage of this extra time? Because 93% isn't bad, but I could probably, in addition to the D800 Direct on-demand nonsense, I bet you I could get that up to 98. Maybe. But I just learned something important here. There's the savings to be had. Yeah, interesting little device. It's like working out the intricacies of you is an interesting challenge, and getting the most out. There's no point in ever accessing directly to an oddball value unless that's what you need, and the difference of 5,000 cycles versus 25,000 cycles is negligible. In the case of my radio player, it probably would be. But for this project, a little bit of reworking of the BBT data is going to pay off.